Hello guys, so welcome to the lecture of basic electrical engineering. Okay, we are covering basic electrical part. Okay, basic electrical part, and we are going to cover the whole basic electrical part. This is our lecture number 10, and these are the topics. As you can see here: effect of temperature on resistance. I think it's visible nicely. Temperature coefficient of resistance, graphical determination of temperature coefficient. Okay, so we are going to talk about temperature coefficient and effect of temperature on resistance. If you are first time to this channel, I request you that please subscribe to this channel. I am making videos on basic electrical part, and we are making so small videos, so you'll not means you can watch per day single videos, and you'll not feel like you're studying or anything. It's so small, 10-20 minutes like that. So let's start. So first topic is effect of temperature on resistance. Okay, effect of temperature on resistance. The resistance varies according to the type of material. Okay, temperature effect means the effect of temperature, but effect of temperature on resistance varies according to the type of material. Suppose one material you have, the resistance of this material is affected by temperature, but also this temperature is means the same thing. The resistance varies according to the type of material. Okay, and depending on the type, temperature also varies. Okay, so number 1 point, the resistance of pure metal increase with the increase in temperature. Okay, here this line will be cleared here within these 3 points for you. The resistance of pure metal, when the substance is pure metal. Okay, in resistance of that pure metal increase with the increase in temperature. If you increase, suppose this is the pure metal. Okay, this is a pure metal substance, and if we increase the temperature of this metal body, then resistance of this substance or pure this metal, pure metal, will also increase. Okay, that is called positive temperature coefficient. Electrolytes. Okay, electrolytes means you can say some liquid type. Okay, those used in transformer, suppose in transformer for cooling. So electrolytes, insulator and semiconductor. Electrolytes, insulator, I think you know insulator means it has too much resistance. Electron current can't flow through it. Okay, insulators and semiconductor is the summation of like adding of insulator plus conductor. Okay, both, that is negative temperature coefficient. And for alloy, when temperature increase, okay, for alloy resistance also increase when temperature increase. For alloys, resistance increase when temperature increase, but this increase is very small, but the increase in resistance, that is very small and irregular. For copper, this graph is given for copper. Okay, temperature resistance graph for copper. For copper, change in resistance is fairly regular for normal range. of temperature. Suppose there is one copper and it's in environment of normal temperature. Okay, in normal temperature copper, for copper change in resistance is fairly regular. Okay, so temperature versus resistance graph is a straight line. This one, you can say this red line one. Okay, this one, the temperature resistance graph for copper. Sorry. Okay, now so temperature resistance graph is a straight line. Okay, if it extended backward, this temperature resistance graph, if we extend it backwards, that it cut this x axis. Okay, this one is x axis, this one is y axis, this one is x axis, this one is y axis. It cut at x axis at minus 234.5 degree Celsius. That means theoretically copper has zero resistance at minus 234.5 degree Celsius. Okay, I think it's clear. Easy topics. Let's go to next. Temperature coefficient of resistance. Temperature coefficient of resistance. Consider a conductor having resistance R0 at 0 degree Celsius and RT at T degree Celsius. Here, let's see this graph. We have this resistance and this y-axis side is resistance, x-axis side temperature. And for a conductor, we are assuming any conductor, the resistance R0 at temperature 0 degree Celsius and the resistance RT at T degree Celsius. Okay, it's clear. This is the graph. We are taking this value and this value at 0 temperature, this value at T degree temperature. Okay, in the normal range of temperature, the increase in temperature. Okay, so in normal range, that so from here directly we are just calculating here the increase in temperature. So increase maximum minus max value minus lowest value. Okay, temperature coefficient of resistance, this will be R. Increase in temperature, this will be not in temperature. If we calculate though, sorry for the mistake, if we write it temperature, that means T0 minus 0 so we don't need to calculate that, so we'll calculate it here. Increase in resistance, what will be the RT minus R0, sorry, RT minus R0. Okay, RT is greater value, R0 is the lower value, so this is the increment in resistance. Okay, it directly this it is this RT minus R0 means increase in temperature is directly proportional to the initial resistance, then RT minus R0 is directly proportional to R0. Okay, this increase in resistance is directly proportional to the initial resistance, so we can write this R0 is the initial resistance, and directly proportional to the rise in temperature. To the rise in temperature. Rise in temperature what? T. Okay. Here to here T. Okay. So RT minus R0 directly proportional to T. Depends upon the nature of material and depends upon the nature of material. Okay, these 3 points you have to remember. In the normal range of temperature, the increase in resistance, if you keep it in bracket, the increase in resistance is directly proportional to the initial resistance, is directly proportional to the rise in temperature, is depend upon the nature of material. Okay, if we now add this number 1 and number 2, RT minus R0, where is yes directly proportional to R0 RT. Okay, so here you can write RT, we just add one constant. Okay, this is alpha 0, this is we have written, this one is called alpha. Okay, this letter, so this is alpha 0. So alpha 0, this alpha 0 is a constant and is called temperature coefficient. So this alpha 0 is called temperature coefficient. You have to remember this equation. Okay, so we can write down from here, alpha 0 is equal to RT minus R0 by R0 into T. Okay, very easy part. I am just telling it a bit slowly so that you can understand very easily. Okay, temperature coefficient of resistance of a conductor. So temperature coefficient what? That alpha 0. Okay, temperature coefficient of resistance of a conductor is the increase in resistance per ohm, original resistance per degree Celsius rise in temperature. From here we can write this one from the last equation. This is the increment in resistance, increment in temperature, this is the initial resistance. Okay, so from there we can write temperature coefficient of resistance of a conductor is the increase in resistance per ohm, original resistance per degree rise in temperature. So copper has a temperature coefficient of resistance 0.00426 degrees Celsius. So what is the meaning of this? We just got to know all this equation, but suppose if anyone says that copper has a temperature coefficient of this much, okay, then what does it mean? It means if a copper wire has a resistance of 1 ohm at 0 degree C, then it will increase by 0.00426 ohm for 1 degree rise in temperature. Okay, so copper has a temperature coefficient of this, that means copper wire has a resistance of 1 ohm. That means if a copper wire has a resistance of 1 ohm at 0 degree Celsius, then it will increase by the coefficient value ohm for 1 degree rise in temperature. So it will become 1 plus the temperature coefficient value. Okay, okay. For any substance, okay, what is positive coefficient and what is negative coefficient, temperature coefficient? We just said before at first page. Also let's For pure metal, okay, for pure metal resistance increase when temperature increase. Suppose resistance increase, then temperature increase, that is positive coefficient. But resistance decrease when temperature increase, that is negative coefficient. Okay, graphical determination of temperature coefficient. So this is the last topic for this video. Here you have to look at this graph. Y-axis versus at y-axis resistance ohm, at x-axis temperature in degree Celsius. Okay, graph AX, a straight line. Okay, temperature resistance graph AX is a straight line. Okay, resistance R0, resistance R0 OA at temperature 0 degrees, at temperature 0 degrees OA, and at RT at temperature T degree Celsius, RT at temperature T degree Celsius. So alpha 0 we know from the before, we just see that one, the equation. Alpha 0 is temperature coefficient. Increment in resistance, increment in temperature, and initial resistance. So from here, look, RT minus R0, RT minus R0 is BC. This is the increment. Okay, this is the initial temperature line, and this is the upper increment temperature line. Okay, so RT, this is the value, this is the increment value, B to C. Okay, T is equal to rise in temperature. T is equal to rise in temperature is A, B. This one, A to B. We can write it down from downside or upside. Here we are taking A to B. This is the increment in temperature at 0, here T. Okay, so if we put those value in this equation, we can write alpha 0 is equal to RT minus R0 is BC, so VC by R0 into T. T's value, T is AB, R0 into AB. Okay, so BC by AB is the slope of temperature resistance coefficient. BC by AB, this BC by AB is the slope of this graph. Okay, this temperature resistance graph. Okay, so the alpha 0 is equal to, we can write slope of temperature resistance graph by original resistance, because we are taking BC and AB, so R0 is there. R0 is the original resistance or initial resistance. Okay, alpha 0 we can write slope of temperature resistance graph by RT, alpha at if it is alpha T, that means it will be RT. Okay, so that's it guys for today. So this will be our lecture number 11, temperature coefficient at various temperature, summary of temperature coefficient relation, variation in resistivity with temperature, and we will do some numerical problem in our next lecture video. Okay, next video lecture. So guys, subscribe this channel, because I am going to cover the whole basic electrical engineering part. Okay, this is gonna help you if you are a BTech student, MTech, BTech, MTech, or any kind of engineering examination. Okay, engineering examination, this will obviously help. Okay, so bye bye, have a good time.